kcse television channel Jamarita High School. Kindly subscribe, click the notification bell such that you get notified once I upload a new video. Today we are looking at questions from crude oil, that is organic chemistry 1. And we wanted to see some of the questions which can be set from the fractional distillation, the fractionating column, which is used for the separation of the crude oil. So in my diagram here, I have two diagrams. We have the first diagram where we have a crude oil, then we have letters A up to G. On the other side, I have another diagram here. So we have this diagram. This one is containing some of the questions here. But when you look at the second diagram, this is a method used for the separation of the crude oil. And now, what are some of the important features that you are supposed to know about this fractionating column? First of all, we have this fractionating column. We have at the top, the petroleum gas is being collected. The petroleum gas is being collected at the top. And what are the uses of this petroleum gas? The petroleum is normally used for as a laboratory gas. It can also be used as a domestic gas usage. We can also have the second fraction. We have the gasoline. Gasoline is normally used for it is fuel for cars. We have another fraction which is naphtha. Naphtha is normally used for making chemicals. Then we have another this fraction. We have kerosene. Normally kerosene it is not used in our homes, so we can say it is used for domestic use. We have also the diesel, which is another fraction. So in this diesel here, diesel can be used for cars, it can be used for lorries, and it can also be used for in buses. We have the fuel oil. The fuel oil is normally used for fuel for ships. It can also be used in fuel for power stations. We have the last part, which is at the bottom. The bottom we normally collect the residue, and the residue is bitumen. The bitumen is normally used for road construction and roofing. At the top here, at the bottom here, the temperature is very high, so this part is very hot. In fact, the temperature is up to 350. And at the top here, it is very cold. It is very cold. The temperature is very low as 25 degrees. Now, from this petroleum gas to petroleum gas to naphtha, where we have petroleum gas, gasoline, naphtha, what are some of their features? In this case now, normally the hydrocarbons which are found between petroleum gas and naphtha, they have these are the hydrocarbons with smaller molecules. They have a low boiling point. They are very volatile. They frost easily, and also they can ignite easily. So these are the features of the hydrocarbons normally found between petroleum and naphtha. Between kerosene and in this case ratio, you will get some of the hydrocarbons here, whereby you can get hydrocarbons with a very large molecules. They can also have a very high boiling points. These hydrocarbons also, they are very volatile. They does not flow easily, and therefore they does not ignite easily. So in that case, those are some of the properties of the hydrocarbons which are found between petroleum and naphtha, and between the kerosene and the bitumen, where we are collecting the bitumen as a ratio. Now, what are some of the expected questions that you are expecting from this particular diagram? What is the name of the apparatus above? What is the name? In this case, we are referring to this apparatus. The name of this apparatus, we just say it is a fractionating column. What is the name of the process which is used in the separation of crude oil? So the name of the process which is used in the separation of crude oil is just a fractional distillation. What physical property of compounds in the mixture does the separation depend? So this separation of this mixture, the crude oil, it normally depends in boiling points of the components. Use letters, these letters, we can say that we use letters A to G, we use letters A to G to describe where the following will be formed. So first of all, you have the fraction that represents gases. The fraction that represents for gases in my second diagram, at the top we have the petroleum gas. So the fraction that normally represents gases, so you can use this letter A. In this letter A, we have normally the fraction which represents gases. We have the fraction that represents the largest molecule. So the largest molecule normally, the hydrocarbons which have a very large molecules is found between the kerosene and the bitumen. So normally you can just say at the hydrocarbon which is at the bottom here, it is a hydrocarbon which is the largest molecule. In this case here, we can use letter G. I mean that letter G represents an element and a hydrocarbon with the largest molecule. The fraction that represents liquid with the lowest boiling point. So the lowest boiling point normally found at the top here, and in this case you can use letter P. Letter P here we have hydrocarbons where we have all these hydrocarbons at this region here, they have a low boiling point. And of course, you can also be asked that, and you can see this model diagram here. How can you separate a mixture of D and water? A mixture of D and water, in this D, the fraction we are collecting here, we are normally collecting kerosene. And we know that kerosene and water does not mix, they form the heterogeneous mixture or they form two layers. So in this case, a separating funnel is used to separate the mixture. So if you are asked to draw an apparatus which can be used to separate a mixture of D and water. In that case, separating a mixture of kerosene and water, we just draw a separating funnel like this one. State the use of the product at G. The use of the product at G. At G here on this second diagram, we normally collect bitumen, and the uses of a bitumen is used for road construction and for roofing. We have also the fraction which is collected at C. At C here, we normally collect in naphtha, and the uses of this naphtha is normally using in making chemicals. Explain how the mixture is separated. Explain how the mixture is separated into these components. How is this mixture separated into these components? The component of petroleum gas, gasoline, naphtha, kerosene, diesel, fuel oil, and of course the bitumen. How are they being separated using this fractionating column? You just say the crude oil is evaporated and the vapor is allowed to condense at different temperatures. You know, we have said that these fractions have a different temperatures because they have different number of hydrocarbons. So in this case here, crude oil is evaporated and this vapor allowed to condense at different temperatures in the fractionating column. The column is hot at the top, the column is hot at the bottom, and cold at the top. So we are saying at the bottom here, it is very hot, the temperature is very high, up to 350 degrees. And at the top there, the temperature is very low. So it is very cold at the top and very hot at the bottom here. So what happens here? Substances with a high boiling point, two substances which have a high boiling point are normally collected at the bottom, and the substance fractions which has the lowest boiling point are collected at the top. And they condense at the top, and therefore they are collected. And that is simply how is the mixture of the crude oil is being separated. Name two naturally occurring mixtures that are separated using this process. So the mixtures which can be separated using this process, you talk of air and also you talk of crude oil. So we have air and the crude oil. These are the naturally occurring mixtures which can be separated using this process. Explain why the constituents of a crude oil do not have a sharp boiling point. Why is the crude oil, the constituents, the fractions have a different? Why do they have a sharp? Why why these fractions do not have a sharp melting point or boiling point? It's just to say they are impure, and the reason why they are impure is because this is because some hydrocarbons are found in more than one fraction. So some of the hydrocarbon carbons are found in more than one fraction, and that is why now the crude oil does not have a sharp boiling point. Name the gas that is likely to be the constituents of a crude oil. Gases which are the constituents of a crude oil, you can talk of methane gas, you can talk of ethane gas, you talk of butane, or you can talk of propane. You can name any. What the conditions could cause a poisonous gas? What the conditions could cause a poisonous gas to be formed when kerosene burnt? A poisonous gas is normally the carbon dioxide. This carbon dioxide, for example, if a stove chico is used in a poorly ventilated room, these gases are very poisonous gas, whereby it will combine with the plant to form a substance called carboxyl hemoglobin, and that one will cause suffocation. So what's happening here that when you are burning kerosene is a group of an hydrocarbon, and wherever a compound that contains carbon and hydrogen is burned, it produces carbon dioxide and water. But in this case, if now kerosene is burned in a limited supply of air, a carbon monoxide is normally produced, and the carbon monoxide is a poisonous gas. So you just say burning kerosene in a limited supply of air, this could lead to incomplete combustion of kerosene. As a result, the carbon dioxide, which is a poisonous gas in this case, is produced. You kindly follow my channel, click the notification bell such that you get notified once I upload a new video. Thank you for watching.